Hello, this is the GCSE 9 to 1 AQA Geography, Paper 1, Physical, Section B, The Living World, video on hot deserts, and specifically their physical characteristics. So first we'll be looking at where deserts are located. So here we have a map, and it shows the location of deserts in yellow. Now these deserts are named, but you don't need to remember all the names of the deserts. However, later we will be looking at a desert case study. So as you can see here, deserts are usually located 30 degrees north and 30 degrees south of the equator. Here in the continents of Africa, South America, North America, Asia, Oceania. Or you could also say they're located along the tropics of Cancer and the tropics of Capricorn, which are along here and along here. Now, here we have a past exam question which says, describe the distribution of hot deserts. So first we're going to be looking for the exam board keyword, which is describe. So according to the exam board, describe wants to give you an account of a phenomenon. So in other words, according to the mark scheme, it says you can credit statements about the distribution of hot deserts using information from the map. So, for example, most of the world's hot deserts lie between 15 and 35 degrees north of the equator. Several deserts are found on the western side of the continent, for example here in southern Africa and in South America. Another point would be the largest desert, which is the Sahara Desert here, stretches across northern Africa into the Middle East. And another point would be some hot deserts extend much closer to the equator, for instance the Atacama Desert on the western side of South America, which is here, and it moves up here. However, what the exam board says that you don't get marks for is for listing continents or places where they're found. So for example saying Africa, South America, North America or Asia. That would not give you marks because you have to spot a pattern. So for example 15 degrees to 30 degrees north, or outliers such as the Atacama Desert, which stretches much further beyond the equator. Okay, so now we'll be looking at why deserts are where they are. So first we're going to be looking here at the Hadley cell. So imagine this is a globe, and here you've got the equator and roughly 15 degrees, 35 degrees north and 35 degrees south, which is generally near to the 23 degrees point of the Tropic of Cancer and Tropic of Capricorn. And here you have your Hadley cell. So, this is the process of the Hadley cell. First of all, hot air rises. This here is the hot air rising, because as we know, hot air rises. However, the hot air can only reach a certain limit in the atmosphere, which I'll just draw on here. And once it's reached this limit, it can't go any higher. So this is it reaching its limit. Now it's reached its limit in the atmosphere, it is pushed either north or south. Once it's pushed north or south, the air becomes cooled due to the high altitude that it's in. So here's the air becoming cooled. And due to the cool air, it means the air is now drier, because cool air contains high pressure, and high pressure air leads to dry conditions. Now the air begins to fall, and falling high pressure air leads to the dry conditions on the ground, so where the deserts are, because deserts are dry. This high pressure air also contains little condensation, so it means clear skies will be located around where these deserts are, and it will also mean that the less condensation in the air leads to little clouds, and the little clouds mean that the air is drier once again because of the less precipitation. So we mark that on here, leading to dry conditions here. Now, once the air has fallen, trade winds are going to push the pressure north or south towards the equator where the hot air once was. Now this is because the trade winds follow a pressure gradient which moves from high to low, the low pressure being where the hot air is. and once it reaches this stage, the air rises again and the Hadley cell continues the cycle.